Hey everyone, you're listening to the Simple Electronics podcast, and I'm your host, Simple Electronics, and with me I have a very special guest. He runs the Unexpected Maker YouTube channel. How are you today?
I am good, thank you. Thank you very much for having me on.
Well, thank you so much for coming on. I always struggle describing my guests to the viewers, so I usually throw it over to the guests. So can you tell us a little bit about yourself?
Yeah, I always struggle explaining to people about myself. I am a maker. My name is Sion. I'm a maker. I have, as you mentioned, a YouTube channel called Unexpected Maker. I'm also now a hardware engineer, and I have turned Unexpected Maker into a hardware design and manufacturing company. So, I'm now doing so many different things that I really can't define who I am anymore, which is fun and also troubling.
Yeah, I think it's way better for you not to be able to define yourself than for me to try and get it wrong, for example.
Right, sure. At heart, I'm a maker. I'm currently finding myself doing not a lot of general making, which is quite frustrating for me because of the amount of other things that I'm doing, the amount of work and production I'm doing. But my plan is to get back into making and producing videos, which is probably my primary passion. Obviously, working hard is great, but it's not really something I'm passionate about. But making stuff is. So I'm still trying to find that balance.
Absolutely. And if we can actually get started on the stuff you make, because I have a very unique opportunity to speak to someone like you, because you actually make your own products. Like you designed your own products. Can you speak a little bit about the products themselves first?
Yeah, sure. So obviously it's in the electronic space. I love working with microcontrollers, and so I've got a lot of different things that I make and I sell, but primarily I build microcontroller boards based around the ESP32. So I've got my tiny Pico, which is probably my most well-known product, which is the world's smallest ESP32 development board. I can't even remember how big it is, actually, to be honest with you, but it's pretty small. It's like 17 millimeters by 29 millimeters in size. And it's like fully packed in with, it's got obviously the general ESP32 stuff, but it's also got extra PS RAM and onboard USB and onboard battery charging and stuff. So, there's no shortage of microcontroller boards in the marketplace, especially out of China, but I wanted to make something with a bit of a point of difference. So I, set out to design the smallest microcontroller board that I could. That, you can get smaller, but they don't have as many features. I wanted to not compromise on features, but also make it as small as I possibly could. And then just recently I've released my Feather S2, which is a Feather format ESP32 S2 development board, with the new chip from Espressif. But I also design and sell other types of things. So I've got a product called Reflow Master, which is a reflow controller board that you connect to a toaster oven or something like that you can do hobby-based reflowing of electronics. And then I've got a range of other things like RGB LED-based 7-segment displays and Wi-Fi clocks and all sorts of things.
Yeah, and because typically my viewers don't like promoting themselves, I'm just going to take the charge and do it for you. But you can actually go to unexpectedmaker.com/shop to pick up these products. And in fact, it was offered to me to get a small cut of the sales on these things, but I refused, and therefore I am being unbiased, and therefore I can tell you they are pretty awesome. Actually, if you go look at the shop, the prices are extremely reasonable, and they'll become even more reasonable as the conversation goes on, but we'll get to that. But yeah, take a look there. If there's something that tickles your fancy, go pick something up, because these things look pretty high quality. So
awesome, thank you.
Yeah, no problem. If I can start out by asking, why did you pick the ESP32 with a whole bunch of microcontrollers to pick from? What inspired you to take the ESP32?
Yeah, so I actually started out playing with the SAMD21 micro controller, which is what I use on my Reflow Master. And some of my first board designs that I made was from the SAMD21. But the ESP32, which was still fairly new when I started playing with it. It'd been around for a little while, but the Arduino support was still very new, and there was only some basic MicroPython support and stuff. It's a fully featured chip, right? It's for its price point. You've got Wi-Fi, you've got Bluetooth, you've got two pretty fast cores, like 240 megahertz cores. There's stack of flash inside them. So the ESP32 went a very different direction in terms of value proposition compared to what else was on the market at the time. Generally, if you wanted to get a microcontroller that had Wi-Fi on it, it would normally be two different chipsets. So you'd have like a SAMD21 or an STM32 on the board, and then you'd also have a separate third-party Wi-Fi chip. This is the first, other than the ESP8266, which had Wi-Fi but no Bluetooth, but it was pretty underwhelming in terms of its peripheral support. The ESP32 packed everything in, and so it just seemed like a perfect chipset to focus on for a while because it did everything. Unfortunately, because it's an Asian brand chip and at a fantastic price point, it's also probably one of the most popular chips that you can get on all of the Chinese boards that you can buy on AliExpress and Alibaba and stuff. And as we all know, the boards you buy from China are dirt cheap, and COVID freight issues aside, you'd get free shipping and it'd get out to you pretty quickly. So I also picked the worst chip when it comes to the level of competitiveness in the marketplace. But I felt like I hoped I could bring something new to the table with the ESP32, which is what led me to the Tiny Pico, which wasn't my first ESP32 board. I had made other development boards with the ESP32 before that, but they were more in line with what everyone else was making. It was just like same stuff.
So what's the big draw of the Tiny Pico? What would be the elevator pitch for why somebody should go on your website and buy the Tiny Pico, for example?
Oh God, yeah, I hate selling my own stuff, as you mentioned.
I mean, I could do it for you, but I think it's better from the horse's mouth, so to speak.
Sure. Well, as I said, it's fully featured. There's nothing missing on it. There's no compromises on it. You've got your USB, you've got your battery charging. I spent a lot of time optimizing the way the power paths work to isolate the whole 5-volt power path from use on the board if you're just running it without 5 volts. So its steep sleep is the lowest steep sleep that you can get pretty much out of any ESP32 development board out there. And it's tiny, like it's really, really small. Like it's the size of your thumb. So there's no project that's not suitable for. Well, that's not true. Because of its size, it's limited on the number of pins that are broken out. There's only 14 I/O on the board. Now, obviously, you can get some other microcontroller boards that might have 20 or more I/O. So if you have a project that you need stacks of I/O for, Tiny Pico isn't for you. But the fact is, most people don't. You connect up a TFT screen or an IPS screen, and you connect up some sensors and maybe some audio and some buttons, and you've still got I/O left over on the Tiny Pico. So I felt it was a sweet spot in terms of size and its capabilities, but it's got everything. And the extra PS RAM was put on there specifically to make it a first class citizen for the MicroPython ecosystem, because obviously with MicroPython you're running a VM inside the chip, and so it uses more memory than you would normally use if you were developing in C++ or C. So every Tiny Pico ships with extra PS RAM to make sure you've got stacks of memory from MicroPython.
And let's not forget the fact that I think is the most important is that this thing is developed and built and shipped from Australia. This is not a Chinese manufactured product. Sure, there's Chinese manufactured products on it, but the final assembly, everything is done all by you. Am I right?
That's correct. Yeah, I designed it. I did all the prototyping. I mean, obviously the PCBs themselves come from China, the blank PCBs, because there's no way I'm going into PCB manufacturing myself. That's messy business. But yeah, all the components are sourced from, I mean, let's face it, pretty much every component that gets manufactured is manufactured within the Asian region, whether it's China or Taiwan or Vietnam. But yeah, all the design and assembly is done by here. I manufacture the boards, I test the boards, I clean the boards, I pack the boards into bags, and I ship them. Yep.
So it's all. So you have basically the agency. You are in control of it pretty much from beginning to end, right?
That's right, and that was intentional. So quite a common way for people to manufacture products, at any scale and at any type of product, is that you design something either in-house or you contract a company to help you design it, and then you go overseas and get a contract manufacturer to manufacture it for you. I didn't see that as part of my journey to build a sustainable business. For me, it's not about control. I mean, control, yes, but not for the reasons that people normally think about control, right? For me, doing the whole process eliminates many issues that I'm not comfortable with using an overseas manufacturer. So using a what we call a CM, a contract manufacturer, it eliminates any ability to be agile with your product or your business. Generally what happens, if I was to get my tiny Picos manufactured overseas, I'd have to obviously find a supplier, trust that they're going to be able to do the level of quality that I want. And that trust doesn't come from them making a sample board. That comes from me ordering a first run and taking the gamble that what I get is going to be good. And then they have a lead time to be able to source all their components, right? And to line up the job for the manufacturing run. But I have to pay up front. So let's say their lead time is 4 weeks or 6 weeks. I have to pay upfront for a certain number of boards. They then go and buy all the parts. It gets put in their queue. They make it. I sit there twiddling my thumbs waiting. And then it finally gets made and it gets shipped to me. And then I have to go and test them, check them, hope that they're all good. Now, the problem with that process is that I don't know how many boards I need. I don't know how many I'm going to sell. So how many do I order? Do I take a gamble on ordering, 1,000, 5,000, 10,000? Then I'm stuck with a whole bunch of inventory. What's if I want to make a design tweak on the board? What's if a component becomes unavailable or, something like that? And it means that I can't be agile. It also means that I don't have control of the purchasing and of the components and making sure that they're actually what I want. And most of the CMs mark up all of the process. So you hear a lot about, people saying, but it only costs, 50 cents each to get them manufactured in China. Well, that's true. A board might only cost 50 cents to assemble it. But the CM will normally add 20 or 30% onto the cost of the parts that they buy. And they'll add 20 or 30% onto the cost of the PCBs that they supply, right? And then they'll charge a fee for testing. And you really want to get your boards tested there before they ship back to you. But then I have to supply a whole range of test jigs to the manufacturer, which costs me money, and may or may not ever get those test jigs back. Then I have to pay shipping back and then pay duty and everything else on top of it to get it back again. And so the costs keep adding up. And I worked out very quickly that it would cost me more to get them manufactured in China, or it would cost me the same to get them manufactured in China, but I would have no flexibility on my product because of it, because I'd be committing upfront to a certain number. So, yeah, I just decided from the very start that the only way that this was going to be doable was to do the whole manufacturing pipeline myself.
Yeah, and that's, I mean, it must have been a little scary when you looked at what you've designed and decided, hey, this is time. This product, I'm gonna take it all in my hands. It's me responsible for everything. Like, what was going through your head? Did you think at any point that you might be soldering these things at home, or was that the idea from the get-go?
Well, that was the idea from the get-go, and I was never scared about it, but I completely miscalculated the number of boards that were going to get ordered. And that was the shocking thing. So what happened was the journey of the Tiny Pico was quite long before I launched it, because it started out as an exercise, and then it started out as a way for me to push myself into miniaturizing my designs and working with some techniques that I hadn't worked with before, right? RF and network matching, and, pushing myself to make my first 4-layer board and stuff. I mean, this was quite a while ago when I started the journey on the Tiny Pico. And it wasn't till, I don't know, maybe 6 months into the tinkering that I was doing, because it was really just tinkering, that I really thought I had a product. And of course, I shared this whole journey with my community on YouTube. And there seemed to be a lot of people that were quite excited about it and wanted to get their hands on one. So I decided to go the crowdfunding route with Crowd Supply. And my honest expectation was I was going to maybe sell 300 or 400 boards. That was it. Like, I couldn't possibly see myself selling more than 400 boards. And my plan at that time was I was going to hand assemble them all. No pick and place machine, hand assemble them all. I actually enjoy hand assembling boards. I'm pretty quick at it, and I'm pretty good at it. I've got a fairly steady hand, which is really surprising. But the campaign launched, and I sold, well, that people backed, 450 Tiny Picos in the first day and a half of the campaign.
Oh, wow.
And that's when I went into panic mode, because I'd already pre-bought all my components for like 500 boards. I'd already started assembling the 500 boards by hand to get ahead of the game, right? So that way, because one of the things that, quite often happens with a campaign is that the campaign runs, and then you find out how many people want them and how many you need, and then you go and order the boards, right? And then people who back it have to wait months and months to get fulfillment of what they backed. And I didn't want to do that. I was already capable of manufacturing them myself, and I already had what I needed here to do it. So my plan was to have a big chunk of the order already done when the campaign finishes, so I could ship within a week or two. But of course, it completely blew out. I think I ended up, there was, 1,550 boards were backed through the campaign. Wow. And there was just no way I could build that many boards by hand. Like, I'd be building them for months and months and months. And probably, having a mental breakdown doing it, because there's a lot of concentration required in hand assembling. So all of a sudden, everything changed, right? What do they say about, like your battle plan in war is that, the second it starts, all the plans, go out the window. Yep. Well, that's what happened with me. And suddenly I was scrambling, trying to find a pick and place machine that I could buy and get it quickly. And I was suddenly ordering, all of my components in quantities of reels. And it was nuts. So I had no choice at that point in time but to set up a small manufacturing space. Now, my plan was to always do that, but not so rapidly, and not in a way where I was buying whatever I could to get the job done, because I had to get the job done, rather than planning what I wanted to buy and how I wanted to set it all up. Does that make sense? Like, I was kind of forced into doing it really rapidly.
Yeah, of course. It's you only had a matter of a little while, and your order increased threefold from what you thought the best case scenario was, right?
Well, that's right. And buying a pick and place machine, I had to wait for it to get delivered. It was 2 weeks to get one, and that was after actually working out what I was going to buy and whatever. So yeah, it was it was rather stressful time, but exciting. Like I wasn't complaining about the situation, but it was extremely stressful, and especially when I had to start buying a lot of my expensive components in real quantities. Like buying a reel of the ESP32s is expensive. Like it's a massive amount outlay, and I was very lucky that I was able to cover that financially. Like I didn't have to wait for the money to come in from crowd supply to do that, but it really stretched me thin. Like it was a gamble, So yeah, it was stressful, but it was exciting, and it kind of pushed me faster into that space than I was planning on going.
Yes. Sounds like you were just hopped on the roller coaster at the very top of the hill, and as soon as you posted your crowdsource campaign, the roller coaster started going down, and you were along for the ride at that point, right?
Absolutely, except then it took a twist because then Crowd Supply wanted to stock the boards as well, and they offered me a deal where they would distribute my Tiny Picos to other resellers and handle all my distribution for me. And so I, had a chat with them about it, and their initial order, which came in while I was making the campaign orders, was 2,000 boards. So they added 2,000 on top of the 1,500 that I had to make. So suddenly I was out buying more reels and more components, right? I think I ordered more reels before I even got my first set of reels in, because it all happened so quickly. And yeah, it just took off from there.
In terms of problem, like this is a good problem to have, right? It is still a problem because you have to solve it, but I mean, it's a pretty good one.
Oh, it's fantastic. I mean, at the time it was completely overwhelming. It was really hard to, I'll be honest, like it was really hard to see the exciting part of it when, that it was that mountain was in front of you, but it kept getting steeper and steeper. It's like, those dreams where you're running down this endless tunnel, and the faster you run, the further away the exit is. Right? That's what it felt like, but in real life, like not in a dream. So, and I was, again, sharing all of this quite openly with my YouTube community. So one of the things I decided from the very start was to, be pretty open and transparent and with everyone about my entire journey. And, people were watching me go through this. It was pretty funny. Like I felt like I was watching myself go through it, like kind of a 2-month out of body experience. But yeah, you're right. It was super exciting. It was a great problem to have, and it was fantastic. It just took me pushing through, and it took me, I think there was 50 days straight that I spent manufacturing, and most days were 12 to 14 hour days. 50 days straight that I did, which is just insane.
Oh yeah,
it's too much. Like no sane person would do that, and I had no choice because I had to deliver. So there was never an option for me not to do it. But it was a pretty silly thing to end up being, having to do, if that makes sense.
Oh yeah, for sure. And just so I can set up the listeners here, I'm just looking at the Tiny Pico online here, and on the very top of it, I count maybe, I don't know, like 20 or so components. And those 20 or so components, they have to be taken out of their reels and put onto the board that has been solder pasted, and then it has to be reflowed in an oven. Now, mind you, if you're going to do 2,000 or 3,500 boards, there's no way you're going to do that by hand, because each of those components requires at least 2 solder joints. So what was your solution? Because we're kind of like coming around to the main point why I contacted you in the first place. But what was your solution to get these things manufactured in your home?
Okay, so I ended up, well, interestingly, the original Tiny Pico, I've actually turned it into a single-sided board now, but the original Tiny Pico was a double-sided board. Oh, so it actually had to be done twice. There was also RAM on the bottom because I couldn't fit it onto the top. Well, back then I couldn't fit it onto the top. So yeah, what I did is I bought a Chinese pick and place machine, a small, what's called a desktop pick and place machine. So it's got 2 pickup heads, and the machine, a pick and place machine, is designed to pick up the components off the reels with these little like nozzles that have both suction and the ability to blow air, and then carry them over to the board and put them in the right spot on the board. So it's an automated way of building electronic boards, and it's the way the industry works. I mean, your iPhones and your Android phones are all made on pick and place machines. Obviously, they're made on $1 million pick and place machines or $5 million pick and place machines. Where I went out and bought myself a $7,000 pick and place machine. So you can imagine the quality difference between the two and the expectation level. But what I decided was, because I needed a machine quickly and I really didn't know what to buy and I had no way of, testing a machine first or anything else, was I bought the cheapest and worst I could get to minimize any loss if it was bad, right? And then I had the determination that no matter what, I would make it work for me, because even if it was really, really bad, it would still be faster than doing it by hand. And because it's automated, I wouldn't have that mental fatigue of sitting there one at a time, putting parts on a board. There's actually, I think, there was 29 parts on that Tiny Pico plus the RAM on the bottom. So 30 parts on that board. And the boards come on what's called a panel. So there are 15 Tiny Picos on one panel, which means you have to assemble 15 boards at once. And the solder paste that gets put on the board before you put the parts down has a limited lifespan that it can be in the open air for before the flux inside the paste starts to dry up and you can't use it anymore. And generally that time is somewhere between 1.5 hours and 2 hours, depending on the paste that you're using. Unless it's a really high-end commercial paste, and sometimes you might have, maybe 4 or 5 hours. Now, at my best, which was not back then, right, I could hand assemble a panel of Tiny Picos, so that's 15 boards, in about 2 hours and 5 minutes. That's doing it by hand. So that's sitting there for 2 hours and 5 minutes, not moving, totally focused, with a steady hand and tweezers under a microscope, placing minuscule parts on a board, trying to not have a shaky hand. And that 2 hours and 5 minutes is pretty much borderline on how long my paste can survive before I get it into the oven. So you can imagine if I had thousands of boards to do at 2.5 hours per panel, I'd have a mental breakdown. There was just no way, I couldn't sustain that, no person could sustain that level of concentration. So I bought this cheap machine and it was pretty average. It took me quite a long time to get it reliable and workable. But because I had so many boards to make and I had no choice, I ended up making this machine do way more than it was supposed to, like in terms of its reliability and capability. I mean, it was still, at its best, it was still pretty average, but I managed to knock out all the boards. And that's why I managed to do it in 50 days. And it was painful and I was, complaining about it a lot because it really was a terrible machine. But it got the job done. But by the end of the job, I said to myself, that's it. I'm going to get a better machine. Like I don't want to use this machine anymore. Like I used it for a couple of months. I moved all those Tiny Picos and then I thought to myself, okay, cool. That's it. That's the end of the life for Tiny Pico. Not the end of life, you know what I mean? But, how many more could I possibly sell? Well, that was a really silly comment to make to myself. Just like I'm only ever going to sell 400, right? Because I think I'm currently now making, somewhere between, well, I'm about to finish my 10,000th board, I think, or I'm pretty close to it.
That's awesome.
I've got a massive order I'm doing right now, another 3,500 boards. Like it's kept going, right? Every time I think, that's the end of the craziness of the Tiny Pico, it starts again. So, which then started me on a whole new journey of pick and place machines, which... Yeah.
Are you gonna autograph the 10,000th? Maybe let's say number 10,000 to 10,010 and sell those separately on your website?
I don't think so. I honestly don't know how many I don't know how many I've made, to be honest with you. Like
you don't know the exact.
I've lost track because I could have worked it out just by the number of reels I bought of the ESP32s, but there was a massive amount that I bought at the start that weren't on reels because at the time I didn't know I needed to buy quantities on reels because I didn't think I was going to sell that many, right? So, I've actually tried a few times to try to work out exactly how many I've made, and I could probably get it within about 400 or 500 boards, but I don't really know.
Okay.
Because I can't just do it based on, looking at my sales orders because, I've had some large orders and then I've had things where I've grouped orders together, like, so people buy my Whopper display and then they could also buy it with a Tiny Pico and an Audio Shield. And so therefore I've had Tiny Picos get bundled with here and then I've sold them individually. And honestly, I've really lost track, but it's somewhere between 9,000 and pretty close to 10,000.
So can we get a little bit of a sense of scale from you? You said it's 2 point something hours. I'm terrible with recollection, so you'll have to forgive me. Right. But it's 2 point something hours of you focusing to get 15 boards made up, sort of, before they go into the oven. Your terrible pick and place machine. Can you let us know, sort of, at the low end and at the high end, how long would it take to assemble a panel?
Right. So the first pick and place machine I had would assemble a panel in about 17 minutes, which is a massive drop, in time. But I would then have to take that panel off, put it under a microscope, and sit there for about 10 or 15 minutes fixing the bad placement that it did. So I'd have to, nudge some parts around to make sure that they're sitting on the pads properly. So when they go into the oven, they don't, that they reflow properly. So when solder paste is reflowed, the process of it melting is called reflow. The surface tension on the pads on the board that the part sits on pulls the part into place. But the problem is if the part is not sitting close enough to the center of the two pads, let's say it's a resistor, and so you've got a pad on the left and a pad on the right. If the part is sitting too much onto the pad on the left, when the surface tension happens when it reflows, it can pull the part off the right pad and only have it on the left pad. Or it might make it stand up in the air, which is called tombstoning. So the less precision of the placement that you get, the more chance that when it comes out of the oven, there's a whole lot of parts that aren't sitting correctly, and then you have to fix them using a hot air gun under the microscope, and have to, it's called reworking, where you reheat up the part to put it back in its place. And these parts aren't designed to be reflowed or heated up that many times. So the aim is to get the part as accurate as possible before it goes into the oven. So surface tension makes everything sit in the right spot. But this pick and place machine wasn't that accurate, especially on the small parts, the 0402 components that I use. The machine was never designed to work at that small level. And, it was pretty only good at maybe doing 60 or 70% of them good enough, and then probably 30% of the parts on every board that it did weren't good enough. And so I wasted a lot of time fixing them, but collectively it was still way faster than the 2 hour mark. It was, let's call it 35 minutes compared to 2 hours and 5 minutes. But it was a frustrating process.
Oh yeah. I purposely only watched like a very few of your videos because I kind of wanted to get the first-hand story from you. But if the listeners are listening, there you have a video where when you get rid of this old pick and place machine, and spoiler alert, he bought a new pick and place machine. There is like a puddle of parts that the pick and place machine, I guess, just chucked. Like I guess it didn't pull the reel properly or something, and the parts just they were lost. They were just literally in a puddle underneath the machine. It's insane how inefficient a so-called efficiency machine was.
Sure. Well, that's my third pick and place machine.
Oh my God, that's number 3.
You're right. So what happened was, okay, well, I'll get to that quickly. I had this small desktop one. I knew, like, it didn't future-proof me at all, right? It wasn't good enough, and I'd always planned on replacing it. So I decided to buy a Neoden S1, which is it's a pick and place machine from Neoden, and it was a machine I'd seen in real life at a show that had way better capabilities. It had 4 pickup heads instead of 2. It could do much smaller components than even what I was using at the time. It could go all the way down to 0201. It was way faster. It was a much better unit. And so I finally decided to upgrade and invest in one, and I bought one. And I bought it just as the lockdown started with COVID. And so it got delivered to me, I think, the second week that we went into lockdown in Australia. And it got damaged during shipping. And it arrived to me in a mostly non-working state, right? And it was devastating because I actually sold my original pick-and-place machine to someone else, and that was gone. And my new one arrived, and I had another order of about 2,000 tiny Picos I needed to build. And I shouldn't have sold my first machine before I got my second one. And so this new one arrived, and it wasn't working properly. And I worked with Neoden, and I worked with the company in Australia that I bought it through. They're a distributor of Neoden called EM Logic. And they were trying to help me fix it, but they couldn't send anyone out to fix it because of lockdown, right? They'd closed our borders. EM Logic are in Sydney. I'm in Melbourne, in Victoria. So they couldn't even cross the border to come in to send a technician. And so I was on video calls with Neoden in China and their support people and their engineers, and they had me disassembling things in the machine and trying to work out what the problem was so they could send me replacement parts so I could fix it myself, because they physically couldn't fix it. And there were no other S1s available at the time. Like there was like a 5 or 6 week delay to get another S1 to replace it because of their production line. And so they couldn't even swap it with another machine. There was no other S1s in Australia at the time. And so I had a non-working S1 machine, and I couldn't pick and place anything. And after about 2 weeks of all of us trying to fix it, and they couldn't really determine what was wrong with it, they basically gave me my money back. The machine was sent back, and they gave me my money back. But I was then stuck with no pick and place machine, and I needed to order something quickly because I had this order to do. And I had lots of orders banking up. And so I went back to the original company that I bought my very first one from. And I bought a machine that was, it was like, on paper, it was not even half as good as what the S1 was. But it was a couple of step up from the original machine I bought from them. And the original machine I bought from them, it worked. It worked as advertised. And so I had confidence that this machine, I knew I was buying something that was inferior to what I wanted, but I was again stuck in a situation where I needed something really quickly, and I wasn't going to trust buying another unknown machine, from China or somewhere, have to wait 5 weeks to get it delivered and not know what I was going to get. So I bought what I thought I knew what I was going to get. And I paid a massive amount of money to get it shipped by air instead of by sea because I needed it really urgently. And it got delivered, and it was an absolute piece of garbage.
Oh, no.
It was faulty from day one, and I started speaking to them from day one, and basically the company that I was dealing with, they just didn't care. They refused to admit that the machine was faulty, and it was just, it was useless. Like, it was worse than the original $7,000 machine I bought. And this was a $20,000 machine. I spent $20,000 on it, and it was worse than the $7,000 machine. And I really, it was terrible. And I had a public fight with them on my channel. I decided to take it to my channel because the issue wasn't that they sold me a bad machine. The issue was that they refused to admit that the machine was faulty. And they were blaming everything else other than the machine. And clearly the machine was faulty. It just was not capable of doing what it was supposed to do, and it was not capable of doing what they advertised it to do. And they still advertise this machine as being able to do something that it can't do. So, yeah, I took that to YouTube, and I basically, unfortunately, turned my channel into a pretty anti this company type I was just building lots of content. I wanted a refund. I kept saying to them, if you want me to stop doing this, give me a refund. Your machine doesn't work. And they refused to give me a refund. They just wouldn't do it. And I suffered through using it. And again, I was back to that, like where I was on the first machine, where I would build a board on it, and then I would sit there. It would build a board faster, so I could build a board in, let's say, 13 minutes. So it was like 4 minutes faster than the original machine. But I'd sit there for 25 minutes fixing it afterwards. So it took me longer to fix each board that came out than it did for it to place it. And again, still faster than the 2-hour mark, but I just spent $20,000 to do the same thing that I was doing on my $7,000 machine. Like it was really bad. And I suffered through for ages until I could replace it with what I really wanted, which was a Neoden 8, which is a brand new machine that came out from Neoden. Their model number is the K1830. We call it Neoden 8. And it's everything I dreamed of on a machine. And I took possession of it, a week and a half ago now. And it's like a dream come true. And what's crazy is that it does exactly what it's supposed to do, which should just be the minimum requirement. Yet my mind is blown because I've never owned a pick and place machine so far that actually does what it's supposed to do, without me having to fight it or fix it. So
can you give us an approximate, like let's say you said that your first machine would often have a 30% fail rate on the small components. Well, what would you say that the fail rate is on this new machine, the Neoden 8?
So I'm still tuning it. Like I'm still learning how to use it. There's half of the software I've never even looked at yet, right? I literally took possession of it a couple of weeks ago, and I jumped straight into trying to get boards out of it. Right now, I can build a tiny Pico panel in 8.5 minutes, which is not the fastest it can go, and the board can go straight into the oven without me touching it. Don't fix one part.
Not a single part.
Not a single part. Occasionally there's a button that's a bit skewed or something, and that's basically because the buttons I chose have a slightly dome shape to the top of the button. And sometimes because of the way it picks it up, the button can shift a little bit. But, we're talking about, maybe one button or two buttons on a panel of 15. And all I do is take it out of the oven, I put it under my microscope, and I touch it with the hot air, and it goes back into place. It takes me all of 30 seconds. It takes longer for my hot air gun to warm up than it does for me to fix it. Right?
That's awesome.
We're talking 30 seconds, maybe a minute. And of all the panels I've built so far, I've had about 6 or 7 now that did not need to be touched. Which is what it should be, right?
Yeah,
that's what this type of stuff should be doing. But, I've never experienced that before.
So, give me an idea. How many boards can you reliably manufacture in a day now?
If I really wanted to push myself, I could probably do 600 or 700 tiny Picos in a day. Or probably more. I don't know. I don't even know if it's worth me trying to do them faster because I don't need to produce 1,000 in a day. That's just crazy. I don't want to work an 8-hour day solidly pick and placing because I don't need to now. If I get an order in for 3,000 boards, I don't have to ship them in 3 days. You know what I mean? I can, there's a fairly good expectation that, if someone orders them, they can wait 2 weeks for them for 3,000 boards and I don't have to kill myself doing them in 2 or 3 days, and which is nice. Where on the other machines, I had to, work 14-hour days because even 14-hour days, it would take 3 or 4 weeks to get the job done. So,
big suppliers, educational places, big suppliers, resellers. You heard it here first. Contact Unexpected Maker and get yourself your large orders in. It may be a couple of weeks, but they will be done.
Sure. Yeah. Although, that's opened up a whole different thing, though, which I'll get to in a moment. But back onto the wastage of the parts. So the third machine I got, the one that was terrible that they wouldn't take back, it had this thing where it just constantly failed to pick up the parts from the feeders. So the issue wasn't that it couldn't place the part properly. right? So it's called a pick and place because it picks the part and then it places the part, right? Well, this machine couldn't even pick the part. So what would happen is it would go to pick a part up and just couldn't pick it up. Like the nozzle could not get to the right spot reliably every time to grab the part from where it's supposed to. And so it would fail to pick it up and it would throw it on the floor. Like literally, just drop it on the floor. And yeah, like this machine wasted easily, if I look at all the components over the time I used it, including all the little tiny ones, it wasted 5,000 or 6,000 components, throwing them on the floor. Wasted, gone. Most of them can't be used again because of things like ESD. I wouldn't trust a part that it threw on the floor to use that back on a production board again. I might salvage some parts and use them on prototyping, but I won't take a part that's been thrown on the floor and then put it on a board that I'm going to sell. So yeah, this thing was just, it was crazy the amount of components it would just constantly miss picking up and throw on the floor. It was a wastage machine. It was incredible. So not only did it cost me a fortune that I will never get my money back for, I mean, the machine's sitting in my driveway right now under a tarp, but it easily wasted $5,000 or $6,000 worth of components over the time I was using it. And I had no choice because I had to get these orders out. So, technically every board that I was making was costing me probably 30% more than it should in the wastage of the parts that it failed to pick up.
That's quite the journey that you went through.
It was. And, someone that I know who lives in Perth who said to me once, and I should have listened, and Paul, I'm sorry I didn't listen to you. He said to me, find the best pick and place you can afford and then buy the next model up, is what he said to me. And I didn't. And now I did. The fourth machine, this my Neodin 8, is that machine. There's no step up. There's no one above this machine that I could have bought unless I move into a whole different class of pick and place machines. And I should have done that on my first, or at least my second one. I should have done that. I should have just bought, like he said, because the amount of time I wasted and the amount of heartache and frustration. There's nothing worse than losing the joy out of what you're doing because you're fighting the machines or the system that you're using to do the work, if that makes sense. Like I always wanted to be making and selling my own boards, and that should have been a joyful experience for me. But instead it wasn't, because these tools were making the process so difficult that I lost all the joy out of it. It was it was worse than a chore. It was, every day was like I'd get up in the morning and I'd say to my wife, I wonder what's going to go wrong today. You know what I mean? Like you get stuck in that headspace. And it was really, it was a bit of a dark period, I won't lie. And most people in my community, my YouTube community, saw that. I became an unhappy Sion for a little while. But I've bounced back. I'm now a happy Sion. I've got an awesome machine that is giving me a bit of joy back again. And now, instead of looking at the frustration of making what I needed to make, I'm now once again looking at all of the future opportunities of things I could make. Like I had some boards that I was going to go into production that I didn't, because there was no way I wanted to make them on the machine I had. Like it would have just been torture. And so I stopped thinking about what cool things I could do and just focused on what I had to get done. Now I'm starting to think about what cool things I can do again. So yeah, hopefully this is the turning point for me where the manufacturing works and I can focus again on designing cool stuff.
This podcast is going live January 7th, January 8th. Is there anything you could maybe tease for the listeners of the podcast? That what would be upcoming? What cool stuff is Happy Sion working on?
Yeah, I'm not going to tease. I'm not going to. I'm going to hold my cards close at the moment. It's a fairly competitive space, and I share on my channel a lot of different things that I'm working on and playing with. I do have some new boards coming out, or I'd like to come out early next year. Some of them I've mentioned, like I've got my Feather S2 is the ESP32 S2 in a feather format, the Adafruit feather format. I also designed one at the same time called the Pro S2, which is compatible with the Tiny Pico. It's a much bigger board. It's a longer board than the Tiny Pico because the S2 has a heap of extra features, but the first 10 pins of the board is compatible with the Tiny Pico, so it works with all of the shields that I designed and other people have designed for the Tiny Pico. I'm going to obviously jump on the new S3 chip that's coming out from Espressive early next year, and so I'll have a range of boards coming out with that. But I've got some other things I'm toying with at the moment, but yeah, I'm not quite ready to. Sorry, to share what they are.
No, that's a tease enough. And plus, I mean, we can just direct people to subscribe to your YouTube channel, and then if they want the most up-to-date news, they can grab it right from the source.
For sure.
Yeah, so I mean, the links are in the description. They're on the screen if you're looking on YouTube, and you should definitely go subscribe to Unexpected Maker. Sion will be happy to see you there, especially during the live streams where you can chat with him, because he has quite the nice community, actually.
Cool, thank you. Yeah, I do. The community's fantastic. It really is. It's I'm quite blessed to have such an amazing group of people. Like, many of them have been, with me since I started the channel, for years now. The same names that came up within my first few months of the channel are still, popping into chat sometimes on my live streams. It's pretty amazing. A very generous and helpful community.
Yeah, absolutely.
It's one of the nice things about YouTube. Yeah.
It's like the best part. The community building is actually the best part. I see the same names coming up in my comment section a lot, and I see the same names that are often in my comment section on my Patreon. So, like, really, the community is, I think, the best part of YouTube.
Absolutely, and the maker community itself is just amazing. Like, it's just an amazing group of like-minded, inventive, creative people.
Absolutely, in all disciplines.
Yeah, very inspiring.
How important is the maker movement to you? Do you feel it resonates with you, or is it take it or leave it type thing?
No, it definitely resonates with me. I think it's if you look at what making encompasses now, it's not just electronics. You've got your 3D printing and your laser cutting and your woodworking and your sewing and it's just so many different types of disciplines have all been mashed together inside the maker community that's what's incredible. Like, there are so many things I've got on my list of that I want to learn, that I want to either learn to just have done or learn to augment my skill set to either improve or expand what I do. And there are so many people out there that have skills in all these different aspects of making that freely share their knowledge and their time. It's just incredible. Like, I've not seen, any other, I'm not saying they don't exist, but I've not seen any other industry, shouldn't call it an industry, but, an industry or a space that has so many people that are just willing to give their time and knowledge to inspire other people to make stuff,
Absolutely. It's a very self-selecting group. And since the maker movement is so vast, you would think that you would have kind of like the whole gamut of people. You'd have some nice people and some dickish people, but really it's pretty self-selected to really open and kind and motivating individuals. I very seldom see a person that is sort of subscribed to the maker community that is not a nice person to talk to. I mean, you could just look at this podcast, for example. Everybody I've interviewed, they're makers, true and true. And they're all fantastic people, and they're all interesting people, and they're all people that are willing to, share their stories, share advice, help out new people. It just seems to be that way all the way through. It's not just in the electronics community, it's the whole maker community, it seems.
Yeah, absolutely. I agree 100%. I mean, you definitely get your people who, enjoy telling you you've done things wrong, or, you should have done it like this, or you should have done it like that. There's you've always got those types of people as well. But in their own way, they're still, even if they maybe don't do it in a very constructive way, they're still knowledgeable people that are sharing their information, I think it's fantastic. It inspired me to start making, it inspired me to start a YouTube channel, and it's inspired me to, along my journey to share what I'm doing and be as, as open and transparent as possible. I make a lot of my products are released as open source, with hardware and software. Like the Tiny Pico is open source, so I have all the design files for the original Tiny Picos on GitHub, and all of the libraries for them. All of the shields that I designed and made for the Tiny Pico are all there and open source. So like giving back to the community is part of what, it's like a full circle thing. I learned from people who were sharing, the projects that they worked on. And so projects I'm working on, I'm sharing and giving back so other people can learn from them, and then they can do the same thing. It's incredible.
Speaking of learning, what is your background? How did you get started in? Because like if I'm just looking where you are now, right? You're a full-blown enterprise, if I can take the liberty to say that. But what qualified you, or what inspired you to get started? Like, how did you get started in all this?
I'm a full-blown enterprise on the tiniest of scales, but yeah.
Still counts.
It does. It does, for sure. So I started this. So I've got an interesting history. I've always run my own businesses, and I've always been in the. Because I'll consider the makerspace a creative space. I've always been in the creative spaces. I had an animation company. I had I had 2 game development companies, and I've always been interested in hardware. My dad was trying to get me into electronics when I was little. We used to get the Dick Smith kits. For those that don't know who Dick Smith is, it's kind of like the Radio Shack kits you'd get in the States, where you get little, you get books and you get little electronics kits that you solder, and it kind of teaches you a bit about electronics while you're doing it. But I used to build those as a kid, but I never really understood how it all worked. And every time I tried to, I'd get a book and I'd try to read up and understand electronics. This is all pre-microcontroller space, right? So I just found that, once I started seeing the maths and started seeing the graphs and trying to understand that space, I couldn't do it. I don't know why, just mentally, it was just, it was a barrier for me. And so I'd put electronics and hardware aside for a while, and I'd, maybe 5 or 6 years later, I'd try again, and 5 or 6 years later, I'd try again. It was really this bad cycle of getting nowhere with electronics. Bought a lot of soldering irons, though. But then when microcontrollers have been around for a while, but, the whole Arduino ecosystem started taking off, and it became more accessible, and then you could play with electronics, but via software, right? You could get a board and not have to understand how the board works or assemble the board, but you could write some software and make an LED blink, or you could write some software and make it display a message on a screen, right? And so that's how I got back into electronics, because I had a software background. And so I started tinkering with making pre-bought electronics do things. And that was fun and exciting. And by doing that, I learned a lot more about how electronics works at a basic level than any theory book or, ever did for me in the past. And so that made me start looking at what was on the boards, and then made me want to see if I could replicate what was on that. So my journey was about disassembling, which pretty much my story of my life. I used to pull every toy apart that I ever got. Never successfully put them back together again, but always pulled them apart. So I started disassembling these, how these boards were constructed, till I got comfortable enough to, design one myself, and sent my first PCB off to, get made. And of course it came back and it didn't work. And then, you work out what it was, and you fix it, and you get your second one done. And yeah, it was it was amazing. It was like eye-opening. So I got to learn by doing it practically rather than trying to learn it out of a book. And it turns out, a couple of years later, I got my diagnosis of having ADHD my whole life, which, explained all of my struggles with concentration and learning out of textbooks, which, used to frustrate my teachers because I never could learn out of a textbook. And that then, everything kind of fell into place. And yeah, I learned practically. So the ability to be able to look at a board from Adafruit and look at their schematic and their design and pull it apart, actually have that board in my hand as well and pull it apart visually and then design my own was the thing that took me to that next level of being able to design my own boards. And there's, with electronics, there's so much still I don't know. I keep saying I haven't even scratched the surface. Of all the electronics knowledge out there, I probably only know maybe 5% of it. So I'm quite excited by what else I can learn. But there's so many other things I want to start playing with, like FPGAs and stuff. And, it's a matter of time. And I've got a laser cutter, which I bought and I love. And I make projects with that. But there's so many more things I want to do there. The same with 3D printing. You buy a 3D printer and the first thing you do is, download other people's designs and print them off, little trinkets or whatever. But suddenly you find an application for it for yourself. And so you just start designing your own parts or cases, which I do. There's no end with the maker stuff of things that you can, access and learn and build. I've got all these ideas of things I'd like to make and they require a CNC and I don't have space for a CNC. So those things are on the back burner. But one day I'd like to, if I ever have the space, get myself a CNC, a milling machine and, that'll give me the ability to make other things that I can't make right now. It's just about getting your hands on stuff and just doing it, I think.
Yeah, I mean...
Wow, that was long-winded, wasn't it?
Hey, that's fine. This is a podcast. This is the place for long-winded. We actually have people that pay attention for more than 5 minutes, unlike YouTube. Yeah, I mean, the laser and the CNC, those are some serious end goals for me. Like, especially like a laser cutter. I don't have space for it, neither a CNC. But I think by sharing my journey learning electronics, because I know nothing about electronics to be quite honest. Like I'm basically only the surface scratcher when it comes to electronics and software. I think by sharing my journey on YouTube, it sort of like maybe not inspires me, but motivates me to work my way up to those kinds of things. Like I've been wanting a 3D printer since the early 2000s when I was in high school and I first learned about them. I first heard of them. They were crude things, but now I bought my first one. Maybe 2 years ago now. I don't know. 2020 has been some weird year, so it's hard for me to keep keep time in check. But yeah, and you know what? When you play with a 3D printer, you get to realize that this is not much different than a laser cutter, in fact. And hey, that CNC machine, that's not much different either. They're just specialized in different ways, but it's still the same thing. It's still stepper motors and the math behind it on a controller board. And I mean, it's all kind of the same, right? So I think eventually I'll work up to it. But yeah, at the moment, there's no space here.
Right. So yeah, I mean, they're all, mechanically they're built in similar ways, but what they allow you to do, although it differs, at the end of the day, they allow you to create, right? Like a CNC and a laser cutter are subtractive, systems where you cut things away to build a shape, where a 3D printer, you add things to build a shape. But at the end of the day, they all give you this ability to, to design an idea and then construct it. But then again, so does woodworking, like it's a laser cutter in CNC is like a saw, or a range of saws in woodworking. You start off with a block of wood and you cut things away and you end up with something.
That's right.
I mean, that's a really crude example. You know what I mean? It's just a different medium you get to work with. But they're automated, where with woodworking, you have to sit and actually do all that work. Where, with these systems, you get to design something and click a button and most of the time, you end up with the product that you designed, right? Sometimes it doesn't work, or sometimes there's a misfeed or something. But yeah, it's just amazing that the possibilities are endless, but they're also, because of that being endless, it's polarizing for a lot of people. A lot of people are really enthusiastic about 3D printing. They go and buy a 3D printer, but then don't find what their niche is with it. They might, as I said, download some things from Thingiverse or stuff, and they'll print some things that helps them, in terms of utility stuff, but never actually find what it is about 3D printing that that they enjoy, other than having something at the end of it.
Oh yeah.
Yeah, it's. But I mean, that's the same with all things. It's the same with electronics. People buy lots of microcontrollers or buy lots of sensor boards with the idea of doing something with them one day, but never get around to it. Or you know what I mean? It's what's it? Everyone's eyes are bigger than. Oh, I don't know what that expression is.
Yeah, basically your eyes are bigger than your stomach. But here at Simple Electronics, I would never do that. I would never overbuy microcontrollers and have them sitting in a bin, about 5 feet behind me as we speak. Definitely, that's not me. I would never do that.
Never do that. We all do it. We've all got, we talk about it all the time, we've all got that drawer or box or something full of microcontrollers that have gone to the, there's nothing wrong with them. They're just, we needed one, but we bought 5 because they're on special or something. It was a good deal. And the other 4 have been sitting in the drawer forever. And they probably never get used, and that's okay. It's guilty pleasures. But it's not like, it's small amounts of money. Like, I would joke to my wife ages ago about, I don't drink. I don't smoke. My worst vices are buying electronics. Right? I mean, I could have so many worse things that I could be wasting money on than electronics. You know what I mean? It's not such a bad thing. It's okay. It's okay to have a graveyard of stuff that you don't use.
It's a productive habit, It's you can build stuff out of it. And I think that's where my sort of hoarding comes from, is that if I have a project in mind, the worst thing that I could ever do is lose momentum on that project by having to wait 1 to 3 months for shipping from something from China, for example. So for me, having stuff in stock makes me feel better about having ideas and being able to execute them. Mind you, this hasn't ended up very well in practice, because I usually end up designing something, I have a certain feature in mind, and I have something like 80% of the components I need for it. And then I still have to wait, 2 months for the last 20%. But I guess it is what it is, right?
For sure. And it's really no different if you were manufacturing, like if rather than buying those parts from China, if you were able to assemble them yourself, you'd still have that same delays, because, you need to design the PCB for it, or you need to, get it manufactured and shipped to you, and you need to get the components to assemble it. Like, it's, no matter which level you get to, I have reels and reels. I've got, hundreds of different types of components here, and I've got enormous quantities of components here. But at the end of the day, if I wanted to design something new today and put it together as quickly as possible, the chances are, other than having to wait for a PCB, if it needed a PCB, there would still be one part that I don't have, or I don't have enough of, or I don't have the exact right component. Like I've got a 10 microfarad capacitor, but in this case I need one that can go up to 50 volts, and I've only got one that can go to 25 volts, right? There's always going to be something that you don't have that you need to get. It's it's about keeping the momentum going while you wait. And there always seems to be other things we can jump onto, which is fantastic, Yeah, most makers might focus on 1 or 2 projects at once, but they're in the middle of 10 other ones or 20 other ones, and they've got all these ideas that haven't even started yet, and they've got all these other ones that they've already abandoned, There seems to be no end in the amount of amount of projects we all start.
Oh, for sure. If there's any sort of aspiring makers that are listening to you right now speak, do you have any advice for someone who would like to build and manufacture a product and sell it sort of at the scale that you do? Do you have any maybe hard-won or maybe not so hard-won advice for them?
I think that, like, if you want to design and make something, do it. Don't worry about how it's going to get made. Don't even necessarily worry about validating your product in the marketplace. It depends on why you're doing it. If it's product-based and business-based, like, if you've got an idea that you want to, that you think can make you a bunch of money, well, I guess like with all businesses, I believe that the success doesn't come from having the product. The success comes from the journey. Like, you know what I mean? Like, most people who don't love what they do aren't necessarily successful in what they do. And people that really love what they do find success eventually, even if there doesn't end up being, financial freedom success. So, but if you've, all that aside, you need to decide if you're wanting to make products or if you're wanting to be a manufacturer, because they're two different things. Like, for me, it's one and the same, because I only saw my journey being sustainable if I did my own manufacturing. But the manufacturing is something that I have to do to get my products out. Which leads me back, so just very quickly, leads me back to a comment that I threw away before, was that because I'm now spending so much time manufacturing, it's eating up all my time, and it's not allowing me to do the other things that I really enjoy, which is designing and, making projects and making videos. Like, my channel's been quite stagnant over the last few months because all my time has been spent on manufacturing. So you really need to decide what you want to do, like what your end game is. My end game was to, have a range of products that I design and make and sell, and manufacturing was just one part of that. But right now, manufacturing is taking over everything just to get everything out the door, and that's a challenge I'm fighting with all the time. If you don't need to be doing the manufacturing yourself, don't. Right? If your focus is on getting a product out the door and supporting the product, or getting lots of products out the door, find a partner to get them made with you, whether it's an overseas manufacturer or whether it's a local manufacturer. I mean, most countries, you can get manufacturing done in any country. Obviously, you pay a lot more generally when you manufacture locally, but maybe that's okay. Maybe the product that you're designing is not a high volume, low margin product, and you can afford to get it manufactured locally, which means you can get it done quicker, and you can be speaking to the people that are doing it for you, and you can, maybe even be on site while it's being made, so you can check things and, remove that stress level of not knowing what you're going to get when it gets shipped back to you from overseas. It's a matter of working out where you want to be, but don't be afraid and just try it. I mean, what's the worst that can happen? The worst that can happen is you design something and it doesn't work. The next level up is you design something and it works, but no one wants it. And then you design something that works and people want it. I mean, it's all part of the journey. You know what I mean? It's they're all good outcomes. In all three ways, you've learned something.
Oh, yeah.
And for me, it's always about learning. I'm constantly striving to learn, to push myself to do more.
I constantly reframe. It's very weird how people have this sort of idea that there's sort of like a path that you need to walk down. And, if you hit a failure along that path, well, then you have to divert and go another direction. The way I look at it is that your path is just going to be a winding one. And whatever failures you have is just going to fork you a little bit onto a different path, but you're still going to end up where you wanted to end up. Like, every failure is a learning experience. So I feel like the word failure is so demonized, when really it's more of like, I mean, the only true failure is if
it's a setback.
It's a setback. Yeah, that's right. But it's not even a setback, because that setback or that failure will actually sort of teach you how to deal with things better. So you'll still get to where you're going, but you'll be stronger for it. Like, fewer things will be able to set you back, I guess, is what I'm getting to. Like, no matter what, as long as you did the thing, you've won. You've gained something. There's always something to gain.
That's right. There's always something to gain. And, some of us, I'll put my hand up on this one, some of us don't, necessarily learn from our first mistake. Sometimes we have to make the mistake a few times before it really sinks in, to avoid it in the future. But it doesn't matter because it's, especially within the maker type space, it's all good learning. There's the worst that can possibly happen is you don't end up with the thing that you were planning to end up with. Like it's the repercussions of not succeeding are really small.
Yeah.
I'm generalizing here. I'm not talking about the person that comes up with this idea of this really cool product and then invests their life saving into it and gets them all made and then nothing happens with it and then they declare bankruptcy. I'm going extreme right now, you know what I mean? But I'm not talking about that. That's about bad business decision. That's not about making mistakes. Just try and learn and tinker. I've got so many people in my community. I call it it's a shared community, right? But in the community that talk to me from my channel and from my Discord server about how they all, say, hey, you've inspired me to design my first PCB and to build, design my first board. And, I've been wanting to do it for so long, but I didn't think I was capable. And then I've made it. And you know what? It wasn't that hard. And now I'm going to, make my second and my third. There's this fear about not succeeding in the makerspace. And so you don't start on a project because it seems like it's too hard or overwhelming or you're not sure how you're going to finish it. So what? Just try, just start. It's never been easier to experiment in this space. It's never been easier to learn and to leverage other people's knowledge. And, the worst case scenario is you might be out, $50 or $100 and maybe a week or a month of your time. But, as I keep saying, there's so many worse things you could be spending your time doing and spending your money on. And none of those things will give you any type of knowledge or build your confidence in any way, tinkering with maker stuff does.
Yeah, and $50, $100 out of pocket and a week of your time, even the cheapest classes are more expensive than that, and you may not get the same experience out of it.
For sure, especially if you're the type of person that needs to do to learn, like I do. I think that's why a lot of people, as we spoke about before, hoard's a bad word, but, buy a lot of electronics and buy a lot of things with the hope that they'll find something to do with them because it's an enabler, just having those items is an enabler that you can, eventually if you get over your fear or your trepidation, you can grab that thing and actually do something with it. But, you look at Adafruit with all their learning guides that, basically you can take any product that they've got that they sell and they've got amazing projects you can make with them where, you can have no knowledge at all and you can still end up with something really cool at the end of it. It's those type of resources. And then, at the next level up, all of the YouTube videos and the GitHub repos everywhere full of, all sorts of software and hardware designs and things you can leverage. It's just a matter of just picking something and doing it and just, seeing where it goes.
And just fake it till you make it. Literally, I've learned electronics relatively late in life, and I have three or four circuit boards that I've designed, sent out to a board house, had them manufactured and shipped to me. Hell, even there's a board house that sponsors me for every video I make using their service. Again, I'm not an expert. I'm still learning along with my audience. I'm just an automotive guy that got kind of sick of the manufacturer saying, yeah, if you test everything around the control module and everything around is fine, then replace the control module. I told myself that's not good enough. I need to know what these control modules are doing in the background so I can diagnose cars more efficiently and more effectively. And so I picked up learning electronics. And literally, what is 2020? We're probably 10 years after me looking at a transistor and going, okay, how the hell does this thing work? Like 10 years. It hasn't been that long, and I'm not learning electronics full time. I'm learning it as I go. So if anybody out there is afraid of getting started, don't be. Just start with someone else's project. Go look at Sion's on his files for his tiny Pico, or go look at let's say a known working circuit and try to recreate it in KiCad, for example. That'll teach you how KiCad works. Like, there's all sorts of things that you can do to sort of fake your way into learning, sort of learning by doing type thing. You just got to do it.
Absolutely. And it's not even faking it, because that's what the process is. You know, like when if I want to come up with a new board for an idea that I've got and I've never done it before, I'm back in the same boat as everyone else. You know, it's like I'm starting from scratch every time. You know, if I want to build I've got an idea. I want to build an RS 485 shield for my tiny Pico. Well, I've never used RS 485, and I understand how the protocol. Let me phrase that. I don't know how the protocol works. I know what it's designed for, but you know, I'm basically starting from scratch. I need to, from scratch, start researching the protocol, start researching what chips are available, start researching what else I need on the board. You know what I mean? Like, it's every new project I work on is like going back to square one again, unless I'm just replicating what I've already done. So there is no, you learn a whole bunch of electronics and then you know it all. You know, every time you want to do something you haven't done before, you need to learn. And there's nothing wrong with that. Like that's part of the joy. That's part of the excitement. You know, you leverage what you already know and you augment it with things that you don't know. And then you push yourself to the next step, the next step. And there seems to be no end of things you can learn with electronics. It's, incredible.
Yeah, and everything new you pick up, you just, put another notch in your belt and away you go on to the next one. It is what it is. Sure, electronics engineers will maybe have an easier time than you, but at the same time, you still have to count all those hours they were in school for. You can't just compare your 2 weeks of picking up YouTube videos to their 4 years of schooling and say, well, yeah, it's easier for them, so it's hopeless for me. That's just not how that works.
True, but those people who spent that long in university, they might have a much better foundation in electronics, right? Especially the non-digital side. But that doesn't mean that if they get given a project, using a technology they've never used before, that they're not back in the same boat again.
That's right.
Maybe just because they understand the mathematics behind how a dielectric works inside a capacitor better than I do. Or they can plot the graphs of whatever of how a transistor cutoff works. At the end of the day, you're putting a transistor on a board and you're putting some resistors on it for biasing, and you're controlling something with it. Well, knowing how that works in theory and actually doing it on a board isn't the same thing. A lot of people who have never done something for the first time, even if they've got a decade of experience with electronics, can and might make the same type of mistakes as someone that's only got 6 months worth of experience.
Absolutely.
Because it's something they haven't done before, right?
And I would go back and add that just looking at your products again, because we need to promote unexpectedmaker.com/shop. Just because someone went to engineering college and got a degree doesn't mean that they can actually think of the utility of the tiny Pico, for example. It takes somebody who wanted, someone had to think about why this would be cool and then make it so it's usable. An electronics engineer would know the theory about how close the memory has to sit to the chip and all sorts of things like that for optimization. But user experience and the way everything is laid out so that it's usable to the end user, that has nothing to do with an engineering degree. That's more of a human-centered approach. Has nothing much to do with engineering.
Absolutely, you're 100% correct. And the amount of work that's involved with shipping a board that has nothing to do with designing and making the board is incredible. I can't underplay that enough. It's, so with as an example, with my Tiny Pico, the board by itself is just another microcontroller board, right? So when I launched the campaign, I decided that I was going to launch the Tiny Pico, but I was going to build a whole range of shields that go with it. Because the board, without a whole lot of things that people can connect to it, is, again, it's just another board that you potentially stick in your drawer. And so I designed a range of shields, from like audio shields and real-time clocks and a display shield and a bunch of other things. And then I had to write drivers for them all. And then I had to document them all, because I was releasing them all as open source. And then I had to come up with learning guides for them. And then, you've got your usual stuff like your website, your marketing and everything else. And then I had to put together examples of how they all work together, so people have a starting block. When they go and get them, they can, automatically put some code on and have something happen. It's like, and it sounds like just really obvious stuff, but that took me way longer to get all that done than it took me to design the board and build it. Designing a board and assembling it and having it ready takes no time compared to all the rest of the stuff. So, yeah, but I guess that comes down to releasing a product as opposed to designing electronics. Not everyone's going to design something that is intended to be sold, or even shared, for instance. There are people who design stuff, they build a one-off just for themselves. That's fine. There's nothing wrong with that. But I guess comes back to your question before about, people who are, what would you suggest to people who are, or what advice could you give to people who actually come up with an idea that maybe want to take it to market? Yeah, just don't underestimate the amount of non-electronics work involved with shipping a product. And then supporting the product as well. Yeah. Oh,
speaking of support, have you had to do a lot of support for the products that you make?
I have, but not in the way that I thought. So I was very lucky that my fail rate of boards being shipped is tiny, to the point of almost negligible. I think of all the Tiny Picos I've shipped, I've maybe had definitely single figure issues. Under 10 boards that I've had to replace for whatever reasons. Most of the time it's unknown, but if it's not working for the user, I'll just replace it. Where I was seeing interesting stuff was that I had a huge number of people that were using the ESP32 for the first time when they got a Tiny Pico, and it was more about the understanding of how the ESP32 itself works, not specifically the Tiny Pico, but the whole ecosystem of how to develop for the ESP32. I guess I made some assumptions that a lot of people who would be buying the Tiny Pico would be people that already knew how to work with an ESP32 and already had their Arduino IDE set up, to work with an ESP32, or had already, played around with MicroPython or something. It was quite amazing how many people didn't even know that they had to, like, what's the Arduino IDE type thing, you know what I mean? So I very quickly had to get, some getting started guides together and stuff for the website, and put instructions on there on how to actually install the ESP32 support inside the Arduino IDE and stuff like that. I mean, in hindsight, that makes total sense. But at the time, that whole realm of support never occurred to me. So I wasn't quite prepared for it. But yeah, it happened very rapidly. So I got all that stuff up very quickly. So I thought that was quite interesting. And at the same time, I also started releasing a bunch of MicroPython videos, because I was quite excited about MicroPython at the time. And as I said, the Tiny Pico was designed to be like a first-class citizen for MicroPython. And MicroPython's always had a stigma in the embedded space. You develop in C and C++ on a microcontroller. You don't use a language like MicroPython that it runs slow because it's interpreted, and it uses a lot of extra memory because blah, 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 and it's so not true on so many levels. I mean, MicroPython is a perfect fit for microcontrollers for so many projects. Not for every project. If you have a time critical, really performance required project, well, you develop in C, no problems, But there are so many, like someone grabs a microcontroller and they design, they write some code that makes an LED blink. I know that's a nothing project, but blink is the first thing that most people play with, right? Like, why does blink have to be running in C++? Like, it's using like not even 1% of the capability, and speed of a microcontroller. So, why can't that run in MicroPython? Like, yeah, I spent a lot of time trying to promote MicroPython and its ease of programming, especially as an introduction to programming on embedded boards. And I think that's why Adafruit are doing so well with CircuitPython. For those that don't know, CircuitPython is a fork of MicroPython. So they're both Python for microcontrollers, but Adafruit took CircuitPython on a slightly different direction on how they make it, and a lot of the libraries and syntax outside of the Python space is quite different. The way they talk to the machine hardware on a board is quite different to the way MicroPython work. So there's two different Pythons out there for microcontrollers. But, the amount of people that are now playing with microcontrollers that never would before because of CircuitPython and MicroPython is huge. It's opened up a world of electronics to people that never would have before if they had to learn and play with C++.
Yeah, my viewers are really getting on me to start doing stuff in MicroPython, and I know I should get onto it because honestly, it sounds fantastic. And I think ESP32s can even be run in Lua, but
yep,
yeah,
and
it's
Rust,
just.
I think there's an interpreter.
Oh,
Yep.
nice. But it's a bit scary for me because I'm not a software guy. I'm hardly even a hardware guy. I'm a nothing guy, really, if you want to look at the general view of it. And so it's a little bit scary to take up something new. So I will do it. I need to do it because I know it's where it's at, and I know once I get comfortable with MicroPython or CircuitPython, that actually it'll open up possibilities because it's a little bit friendlier than C++. I would say it's a lot friendlier than C++.
Yep.
But yeah, it's taking that leap, right? And right now, I've got 8 students that rely on me to come up with new stuff to do every day. So it's a little bit challenging finding the time, the mental acuity to tackle something like changing languages, for example.
For sure. And I think that's a problem just in general with electronics. Like, there's everything that you want to, everything that's the next step in learning seems to be a massive step, like, you want to learn a new language. Well, you can't really learn a new language unless you sit there and actually code in it. You need to actually write in it and to understand it and make mistakes in it and, and put together a library of knowledge that you've done to learn a programming language. That's what I believe. And that's the same with when you're playing with new technology with electronics. Like, you can't just tinker with an FPGA. You know what I mean? Like, to do anything with FPGA, there's so much groundwork you need to learn first beforehand. Or you can't just tinker with writing a driver for a chip. If you get a new chip and there's no driver out there for it and you want to play with the chip, then, you need to learn about, the protocols that the chip uses. And then that might mean that you need to learn about how I2C works at a really low level or how SPI works at a really low level. And then there's that. There seems to be all these barriers to learning to get to the end of what you want to do. But every step along the way of that bit of learning is knowledge that you can then use for all the other things that you want to learn, if that makes sense.
It makes 100% sense, yeah.
Yeah. So, like, yes, learning a new language like Python is hard, or MicroPython or CircuitPython, but you can also learn Python because the Python part's the same. You could learn Python just on your computer, and you don't have to be, it doesn't have to be microcontroller based. You can just, open up a REPL on your computer and just type in some Python and learn it that way. And you can do it over time. And you can accumulate your knowledge and then stick it on a microcontroller. One of the nice things about CircuitPython is that one of the requirements of being able to use CircuitPython on a microcontroller is that the board acts as a USB mass storage device. So like with my Feather S2, you plug it into your computer and it just appears as a USB drive. And you can literally file open in your editor of choice, write some code and click save, and then that code is running on the board. Whereas something like MicroPython, you need to write your code and push the code onto the board through different means. So it's made Python, like CircuitPython has made Python way more accessible on microcontrollers for people because it works just like working on your computer. And unlike something like C or C++ where you have to write some code that's difficult to read for most people unless you're proficient in that language, and then it needs to be compiled down and then run on the device, and then the errors that you get back are often cryptic or you don't even know why things aren't working. With Python on microcontrollers, you're writing code real time and you're seeing the results of it real time. And the errors you get back are Python errors that are really easy to understand. So yeah, the barrier you should definitely jump onto it because it's really not hard. You can, you don't have to learn the whole syntax to, start doing anything interesting. You can take it, one step at a time.
Yeah, that's very likely how I'm going to tackle it. And listeners and specifically my audience, I guess, it's coming. It's coming. I'm getting 2 weeks off for Christmas. I've had 2 weeks off for Christmas, so I used that time to learn. Yes, this is how it's going to go.
Cool.
I don't want to keep you all day because I already feel guilty about taking someone's time. So there's a question I usually throw to all of my guests, and I'd like to throw it to you. The setup of it is that there's a government agency, so I just use government agency because just think unlimited funds. They want to pay you and fund you to start a business of your choice. The business does not have to be profitable, but it does need to provide a service or a product. What do you think you would start?
Oh, wow. I need time to think on this. I'd be starting what I've already started. Like, you know what I mean? Like I would start a business that designs electronics products and accessories around that allows people to build cool projects. That empowers people to build whatever they want to build. Like, so when we were speaking the other day off air, I mentioned that there was a period of time in our history recently where, because of automation and because of mass-produced consumer products and stuff, so many people had forgotten how things work or didn't want to know about how things work or how to make things or how to fix things. And recently, through the maker space, we've had this resurgence of people who are learning how things work again and learning how to make things, which means you also learn how to fix and maintain things. And I think that's been a turning point, and where it's really exciting that, I learned how to do, I learned how to use some tools to do certain things in my garage, and then all of a sudden I'm not so afraid to look at my leaky pipe in my bathroom because I can understand about how tools would work to fix that leaky pipe, which then extrapolates to understanding other things that are more complex. You know what I mean? Like, I feel like there's a large proportion of people that are excited about understanding how things work again. And so building a business that revolves around making, I call them products, but because they are, but making things that are enablers for people to flex their desire to build things. That's what I want to. That's my focus. That's what I would do if I wasn't already doing it, but I'm already doing it. If that makes sense.
It's a very eloquent way of putting it. So basically the way I picture, because I feel like your success is on an upwards trajectory. I don't have access to your numbers, so I'm making assumptions. But if I look at what I see on your website and just speaking to you about your outlook for the future and sort of the way you speak, the words you use and sort of I guess the hopefulness I hear in you, I feel like what you're describing, having a business enabling people to make things, I think it's basically just your web shop in, a couple of years from now. It seems like you're heading in that direction. And I don't see any indicators that you're going to fail at your mission. So I'm really happy to hear about that. That's exactly what you should be doing because that's what you wanted to do.
Thank you. Yeah, look, it's a lot. I've got a long journey ahead of me. Right now I'm doing it all myself, which is not sustainable. I need to solve a lot of business decisions, like in business issues. Issues is not the right word. Challenges. I need to solve a lot of business challenges going forward. I need to grow to be able to keep this sustainable, and I don't know how that's going to work yet. But it's not stopping me from moving forward. But yeah, it's the keeping focus on why I'm doing it. I mean, I'm doing it for two things. Obviously, I want to, provide for my family, which is kind of important. I mean, this is my sole income, which is, makes it even more of a challenge and because there's a lot more riding on it. But the end game has to always be there. Like sometimes it's easy to lose sight in it when you're stuck in the whole profit and loss scenario of a product, and that type of thing, and when you're trying to justify whether it's worth doing something or not. But yeah, just to remembering that it's all about, making things accessible for people that they can do stuff with, that they can, inspire them to, whether it's do something they haven't done before or completely change their life and change their vocation. I mean, because that's what happens at the moment. I mean, just like I did, and just, what so many people I know have done is becoming a maker or getting into the maker space has completely changed their direction, in what they want to do and what they, with their life and where they want to go from a vocation point of view. I just have to keep that focus.
Absolutely.
Moving forward.
Yeah, and I think you're gonna do great. It looks like you've got all the right stuff, and I think if our listeners can go onto your website and just take a peek at what's available there, you're gonna get an idea of what this is all about, and I think they're gonna buy into the idea as well. And so, I guess the only thing left now is to tell people where they can find you. Where do you want them to go find you?
So yeah, I have my website, unexpectedmaker.com, and I also have some of my products on my Tindy store. For those that aren't aware, Tindy is an online marketplace where a lot of makers sell their electronics products and projects. So you can definitely look there. And you can find me on YouTube under Unexpected Maker. I also have a Discord that you're welcome to join. There's stacks of people on there that have a wealth of knowledge. And if you have any questions about electronics and coding in general, there are lots of people on there that can answer your questions for you. And then the usual social media stuff, Twitter, Facebook, maybe not for much longer.
All the relevant links to find Sion and Unexpected Maker are in the description below on the screen if you're listening on YouTube, in the show notes if you're listening anywhere else. And I want to thank all of you for listening. Sion was really nice to have given us his time today, and I want to thank you so much for joining me on this conversation. It was really good.
Yeah, thank you for having me. It was great. I like talking about my journey. Don't like promoting myself, but I like talking about my journey. I hope that others can be inspired by it and learn from it. And I really appreciate you taking your time to interview me.
All right, have a good one, guys.
Catch you later.